In section 3.4, we're going to be working on finding slope and the rate of change. Well, slope is a measurement of rate of change, so we're going to be taking a look at that. So we're going to find the slope of a line, and we're going to interpret slope as a rate of change. Okay, so our key vocabulary here is going to be slope and rate of change, and let's talk about that for a bit. So when we want to find the slope of a line, what we're really talking about is we're measuring how much one thing changes in relationship to another. And we're looking at the slope being how much it changes vertically divided by how much it changes horizontally, or rise over run, which would be the change in y, which you might denote as delta y, over the change in x, which would be delta x, delta being the designating change. And the way we would calculate it is we would find the difference in the y coordinates and the difference of the x coordinates and create this ratio. Okay, so y2 minus y1. It doesn't matter which point I decide to be 0.1 or 0.2, but what's important then is that the x, if I say this is 0.1, then both the x and the y are x1 and y1. And if I decide this is 2, these are x2 and y2, I can't put x1 here and y2 in the same point. That doesn't make any sense, okay? Which one you call 1 and which one you call 2, that's totally up to you. So when we look at finding slope, right, again, I've got x's and I've got y's, and an x and a y, and I'm looking for the change in y, so 3 minus negative 3, I'm calling this 0.2, by the way, over 7 minus 1. So I have the x, the y coordinate in the second point minus the y coordinate in the first point to find their difference. 3 minus negative 3 is 6. And the difference between the x coordinates, 7 minus 1 is 6. So my slope would be equal to 1. Okay, if I do the same thing here, I'll have 1 minus 4 over 4 minus negative 3. 1 minus 4 is negative 3. 4 minus negative 3 is 7, so my slope is negative 3/7. Okay, if we went ahead and did these points, I'll have negative 3, sorry, not a comma, negative 3 minus negative 3. So you can see that the y coordinates are the same, and then negative 5 minus 5. So I'll get 0 over 25. That's a slope of 0. And that's the slope of a horizontal line, which just makes sense, remembering this numerator is vertical change. A horizontal line has no vertical change, right? It isn't going up or down, it's just going right and left. So that's logical. But that's what it means when your numerator is 0. You have a horizontal line. Okay, if I go ahead with these 2 points, negative 6 minus 0 over 0 minus 0, I'll get negative 6 over 0, and I can't divide by 0. So this becomes undefined. And that's logical for a vertical line, because if we look at that, here's a vertical line. How can I say how steep it is? It's infinitely steep. I can't calculate it. Okay, so in this case, there's no horizontal change whatsoever. That's what it means when the denominator is 0. So it has to be a vertical line. Okay, so when we take a look at the different types of lines, we're always going to read from left to right. If it rises from left to right, it's got a positive slope. If it descends from left to right, it's got a negative slope. When it has no vertical change, it's horizontal, and when it has no horizontal change, it's vertical. Okay, so now if we want to start talking about rate of change compares the quantity, the change in one quantity to the change in another quantity. So for instance, if I'm paid $60 for working 5 hours, right? I know that my pay changes $60 for every 5 hours. And I've put dollars in the numerator because normally when we talk about wages, we're talking about dollars per hour, not hours per dollar. So that's what puts dollars in the numerator. And when I simplify this, this just becomes $12 per hour because 5 goes into 12 60 times. Okay, so for every 1 hour I work, I get $12. It's another way to think of it. In this problem, I've got a table of values. So if I look at the table of values, I find the cost of using a computer at an internet cafe for a certain amount of time. So if I'm there for 2 hours, it costs me $7. If I'm there for 4 hours, it costs me $14. If I'm there for 6 hours, it costs me $21. So we want to break this into a rate of change. Okay, so if I go ahead and calculate the slope, right, if these are my x's and these are my y's, I'm going to take these two and these two. I'm going to call this point 2 and this point 1. And I mostly did that because I noticed that I want a positive numerator if I have a choice. So 21 minus 7 is 14 and 6 minus 2 is 4. Oh, look, that's this point as well, isn't it? That's interesting. And if I simplify this more, this will be 7 over 2 or 3.5, right? And that's going to be dollars per hour. Okay, I didn't want to just assume that the rate was constant, right? But you can see that in each case, if I take 21 divided by 6, that's 3.5. 14 divided by 4 is 3.5. 7 divided by 2 is 3.5. Okay, so that's calculating a rate of change. Now we're going to take a look at analyzing a graph. So here we have a graph of the play attendance in different weeks of a performance. So community theater performed a play every Saturday evening for 10 weeks. And the graph shows the attendance for the performances in week 1, 4, 6, and 10. If we want to find the rates of change using the slope formula, so you can see I have 1, 2, 3 different rates of change. Okay, so for the first 4 weeks, we have 232 minus 124 divided by 4 minus 1. So the 4 minus 1 part's easy, that's 3. And 32 minus 24 is 8. So this is 108. Okay, so 108 minus 3, that looks like about 36. So in this case, we had 36 people increasing, 36 more people per week as we increased. If I look at the next weeks, from weeks 4 to 6, I have 204 minus 232 over 6 minus 4. 6 minus 4 is 2, that's easy. But this number is going to be negative, and it's going to be 32 minus 4 is 28. So 28 divided by 2 is 14, so they lost 14 people per week for the next 2 weeks. And for the final 2 weeks, 72 minus 204 over 10 minus 6. So that's positive 4 in the denominator. And the difference here, it's going to be over 100. And then 104, 28, 132 is the difference. And then that item divided by 4 is 34 people per week. Right, so at the beginning of the run, it increased by 36 people per week. In the middle of the run, it decreased by 14 people per week. And by the end, it was decreasing by 34 people per week. Okay, but again, I'm just comparing using this equation that the slope is equal to y2 minus y1 over x2 minus x1. Now, when these are related to time, there really wasn't a choice about which one was the second point because they occur in order of occurrence. This was the first point, the second, the third, and the fourth. I wouldn't want to mess with that, even though it wouldn't really change my calculation. And then if I wanted to just interpret this graph by looking at what happened, I've got a student commuting from home to school by walking and by riding a bus. Well, I can see for minutes 1, 2, 3, 4, from minutes 0 through 4, he walked to the bus station. You see, he's not traveling any distance at all from here, so I'm just going to say this is 1, 2 2 minutes, right? From 4 to 6 2/3 minutes, he waited at the bus stop, waited for the bus. And then for the last 1/3 of a minute, it looks like to me, right? From 6 2/3 to 1, 2, 3, 4, 5, 6, 7, he rode the bus. And you see his rate, his distance is much faster, right? The steepness shows you how fast. He was very slow walking, very fast on the bus. Okay, so that's just taking a look at what was going on in this graph and interpreting it into English in terms of what actually was occurring in the world.